So some of the things I'm going to say are going to be somewhat obvious for this audience, but so to put it in context, when you think about the agenda of many of us have, is try to understand where bad policies come from. Okay, how can we have bad policies? And many of the traditional explanations have to do with the interaction of some of these elements or some of these elements alone, like politicians facing bad incentives or having a bad selection of politicians, and this due to maybe poor institutions or other features, or interaction with pressure groups. And it's from these elements that usual theories of bad policies, these are the basic ingredients in many of the theories of bad policies. And in this paper, in a way, we are just trying to move a little the focus towards the role of voters. And in a way, you could say that it's a theory paper in the sense that we have a theory. The theory is, or we don't have a model. The theory that I want to put forward is that voters may demand bad things, and not because these are bad people that have preferences that do not align with our preference. That's not what we mean. We mean that they may demand things that are bad for them, or policies that are bad for them, simply because they don't fully understand the effect that those policies will have on outcome. They cannot think, some of them may not be able to think in terms of equilibrium, and therefore when they make a prediction about how policies will affect outcomes, they make a bad prediction. And that's why they demand bad things. And then this bad demand may affect the supply side. That is what we usually worry about. Our focus is on the demand side of policy. Of course, we don't want to claim that people can be so silly to keep demanding bad policies when they have the information to identify that actually they are not getting what they're supposed to be getting, or what they thought they could get from those policies. So in general, we may think that it's more about an unfamiliar situation, or a situation that is not so easy for the people to identify the relationship between policies and outcomes. There are many situations that we may think this happens, that we may be unfamiliar, issue of privatization, the regulation, many examples, healthcare reform, carbon tax, and global warming. These are cases in which you may think that it's difficult to predict what is going to be the final total effect of a policy, because you may not know exactly how people are going to respond to these incentives. In terms of healthcare, you may not think about adverse selection and stuff like that. In terms of carbon tax and global warming, you may not think about how others are going to respond to the tax in terms of reducing their emissions. In these cases, equilibrium effects may be important. Okay, for example, in the carbon tax example, it may be easy for us to see that the tax is bad in the sense that they want to take money away from me. It may be more difficult to see that the tax may be good because it may change the behavior of others. Okay? The problem with any of these examples, we may start arguing about, no, the direct effect, indirect effect exist, they go in the same direction, they're not. And therefore, we are not going to use data from any of these cases. We're going to do an experiment to see that this tension between direct and total effects may be important. So now I'm going to maybe use this simple example on the one hand to put a little more precision on the theory, I shouldn't call it that, but the idea. And also this silly example is going to be what we're going to bring to the lab. Okay, so I'm going to spend maybe too much time on the prisoner's dilemma, but it's going to be useful to have this very clear so that then it's easy to follow the experimental results. So this is a simple prisoner's dilemma. People can play, it's a two-player game, they can choose C or D. And of course here we have if we assume that these are people's utilities, in the experiment this is going to be money, but if you assume that this is people's, let's assume that people only care about these payoffs, then we know what is going to happen. The Nash equilibrium is different, with a payoff of 5. But we could, society, if it has a power to enforce taxation, could agree on imposing a tax of 4 points on defection. That would make the 11 become a 7 and the 5 become a 1. And impose a tax of 1 on cooperation. That makes the 9 becomes an 8 and the 3 becomes a 2. And this is a very different game. So we have we impose a tax system that is not the same for, depends on your action, how much you are taxed, and now the dominant strategy is to cooperate in this alternative gain, and the equilibrium goes to cooperate with a PF of 8. Okay? Notice that regardless of the outcome, you're better off in the prison. Leaving the outcome constant, you're better off in the prisoner's dilemma. That's essential. So if you think that, but of course in equilibrium what the taxation does is it changes the outcome. But they may not realize, they may have, in their heads they may have a different theory of how people will behave, and their theory may be they will not respond, and therefore why should I vote for taxation? Okay? So here, there are the direct and indirect effects. You know? So there is a direct effect that is bad of taxation, and the 9 becomes an 8, and so on and so forth. There is an indirect effect that is good affecting the behavior of others. If the taxation makes others cooperate, that's good for me. Okay, so this is direct and indirect, and therefore at the end we have a total. And these two things may go in opposite direction. And our theory is basically some people may have a tendency to focus too much on direct effects and underappreciate indirect effects. This is a case in which they go in opposite directions, but they don't have to. So what we're going to do is to provide an example from an experiment in which we observe this. Okay, we observe that some of the subjects seem to focus too much on the direct effect and not on the total effect. And then we are going to provide evidence that tell us, well, not only that happens, but we can show evidence that is consistent with this underappreciation of equilibrium effect. So not only they will vote wrong, but we will be able to see that how they vote is consistent with our theory of underappreciation of equilibrium effects. So basically, in this paper, we're going to provide experimental evidence of that these guys are voting for the wrong game, and we are going to vary the voting institutions and the initial conditions, and this will help us rule out certain reasons for this, alternative explanations for this. Maybe that would have been a better answer. There are competitive hypotheses that will give us the same mistake and may not have to do with indirect effect, for example, the status quo bias. And we will see that it's more than that. And we will show evidence in favor of this idea of the non-equilibrium thinking that is making them choose the wrong thing. Well, the implication, we can have bad policy even when we have perfect politicians and institutions and no pressure groups. Okay? And that in many cases there may be a wedge between the revealed preferences of voters and their real preferences. But usually we don't assume that there is any wedge there. So this is experimental design. So I'm going to take some time explaining this so that then things are clearer. So this all lab experiment interactive computers, subjects arrive to the lab and they are randomly divided into a group of 6. This is anonymously done. And they will play 5 periods or rounds of the same game, once with each of the other members of the group. This is a group of 6, you're going to play 1 with each of the other guys. This is known. Everything I'm going to say is known by everybody and commonly known. And after these 5 periods, part 1 ends and you go to part 2. You have now new groups of 6 are randomly constructed again. Of course, you don't have too many people, so you may play again, you may be in part 2 with some of the guys who participated in part 1. So it's not perfect separation.
What kind of game you play?
Yeah, so here you could play the prisoner's dilemma, or the alternative. Always the same game in part 1. Like one of the treatments is going to be playing PD and one of the treatments is going to be playing alternative. So that's one of the things that we are going to vary. To see how this is related to your presentation, how the path affects your voting. At the beginning of part 2, there's going to be some type of institution that chooses between prisoner's dilemma or the alternative game. And that's the blue rectangle. That institution is also going to be one of the things that we vary across treatments. And I'm going to explain what these different institutions are and why we have these different institutions. Then, in many of the treatments, it is going to be a belief elicitation stage. This is after the choice of the game, which may involve voting. And this belief elicitation is done so that we get a sense of what is the subject's opinion about the effect of taxation on behavior. So this is going to allow us to say something about this indirect effect. So we are not only going to look at how people vote, but also how this is correlated with their perceptions about the effect of taxation on behavior. And then they go to play 5 periods, once with each of the other guys, either the prisoner's dilemma game or the alternative game, depending on what happened here. The belief elicitation is incentivized. And then this is not very important. At the end, they play a beauty contest game. It's this game of choosing a number between 0 and 100, and the winner is the guy with the number that is the closest to 2/3 of the average of all numbers. This was done to elicit some type of strategic sophistication. This is not going to be correlated with voting, which is interesting. And then we have a questionnaire to elicit things. Also, this is not first order in the paper, but yeah, we have an idea of gender, ideology. Class is not social class. It's freshman, sophomore, junior, senior. Major or concentration, that's what you study. And SATs is self-reported SAT scores. That's the exam for entering the university. What are the treatments? We're going to have 6 treatments which combine different elements. So this is a treatment called control. They will play the prisoner's dilemma. They start playing the prisoner's dilemma. After 5 periods of playing the prisoner's dilemma, room, new groups, and then the computer randomly decides whether to keep playing the prisoner's dilemma or switch to the alternative. This is random. There is no voting here. Okay. Why did we do this? Well, to address the issue of what do people do in these 2 games? Which game is better? We have a reverse control in which we start with the alternative game and then they go to either the prisoner's dilemma or the alternative. So these are the 2 controls. Then we have these controls also are used to incentivize the belief elicitation. That's like the truth that the other guys will have to match. Then we have what maybe is the baseline case. It's a random dictator institution. So this blue institution is a random dictator. We ask everybody to vote between the 2 games, and then we consider 1 vote randomly. So it's not majority, it's just 1 vote randomly. So we have, but everybody votes. No? And why did we do a random dictator? Well, we are also going to have a majority, no? But we wanted to have a random dictator because there you don't have to worry about other voters. Like there is no information. Your pivotality doesn't tell you anything about others. So you can really get at the person, and there can be no strategic considerations in voting there. So we really want to see the demand that cannot be contaminated for some type of strategic voting. But you could say that the random dictator, if we find that a lot of people vote for prisoner's dilemma there, well, they were playing prisoner's dilemma, so maybe just there is a fear of change. So we did another treatment which is a reverse random dictator. They start playing the alternative game and then you give them the choice. So that will help us control for any status quo bias that may be. But of course, what we want to see is, would this also, if there is a problem in these dictators, would you also have a problem when there is majority voting? Majority voting can affect voting here for 2 reasons. One is what I said about pivotality. Basically, if I'm pivotal, means that the other guys are, there's a lot of guys voting against theory, so maybe I shouldn't use theory to predict behavior. And therefore, maybe I prefer to stay in the prisoner's dilemma, even when I know, even when I can do theory. Just it doesn't apply to these people. There will be one difference between dictator and majority ones, but majority can also affect things because once we are voting as a group, maybe we think differently. And so this works both different ways. Maybe when I'm voting, think, oh, maybe I tend to think more about the common good or society as a whole when we are voting relative to being a dictator. And then there we have two different types of majority. We have majority ones, in which there's only one vote here. And then we have majority repeating, in which this blue institution gets multiplied before each period. Okay, so this is the characteristic of the session. So we run experiments both at Berkeley and at Brown. We have a total of 768 subjects. Random dictator has more subjects. That was agreed before we started running experiments. The reason is that we thought that we consider this as our baseline focus treatment, and we wanted to have more power there to disaggregate data inside, as we're going to do later. But it doesn't matter. With this, finally, with the number of observations, everything we can do here, actually, we can do it in the other places as well. So the experiment lasted, it was a very short experiment. It's 10 periods of decision plus a voting, and 11 with a beauty content, and then a very short questionnaire. It ended always in half an hour, 40 minutes, and they made around $28.
So those are the total number of subjects?
768. Yeah. So this is this important issue that we want theory to work in one dimension, and in a way we want to show that it doesn't always work in the other. And so this has to do exactly that. So these are the control treatments. This is control, and this is reverse control. The first graph, the graph on the left, is just cooperation rates. Here in the y-axis you have cooperation rates, in the x-axis you have periods. This is part 1, this is part 2. So in part 1, in the control treatment, everybody was playing the prisoner's dilemma. Why do we have two lines? Well, because these people ended randomly in period 2, in part 2, playing an alternative game. Okay? So what you can see, this is a guy that, with an average of guys that were playing the prisoner's dilemma. As usual, they cooperate too much, but they learn, and cooperation collapses to close to 10% that is usually observed in prisoner's dilemmas. But once they are moved to the alternative game, immediately, boom, goes up. So it's not that they have to wait a time to learn how to move. Immediately they think about it. When they play, they think about it, and most of them, around 90% change. It's like an 80% change. You know? Doesn't go from 0 to 100. It goes from 15 to whatever, 90. Okay? And then they stay around there. These are the guys that stay in the prisoner's dilemma. There is a usual restart effect, and then that hope from change collapses. That's behavior. This graph is the same graph in periods. These are the p-values for period 6 and for all part 2 periods, and the things are highly significant. We are clustering by session, I believe here. Yeah. If you do reverse, you find something very similar. In the alternative game, so here is the first part of the experiment, everybody playing the alternative game, you have very, very large cooperation rate. So in a way, this is much closer to Nash than this is, because there is no tension here, as Tom was saying. And then, when they go to the prisoner's dilemma, there is more than 50% of them immediately adjust, around 60%. And then they learn to adjust even more. And this also results in a significant difference in payoff immediately after reform. This already said this. Nash equilibrium works if you want to rank games in terms of behavior or in terms of payoffs. So the Nash equilibrium works well. You would say it's not Nash, it's dominant strategy. So this is simpler. And this is half of the results, if you want. Here you have all treatments and how people voted. Okay? Theory says very easy. There is a difference on behavior of 100%, that's greater than 50. Everybody should vote for the alternative game. And that's far from what we find. So this column tells you what percentage of subjects in each treatment voted for the prisoner's dilemma. That number should be 0. and it's far from zero. It's around 50%. The last one, this is immaturity repeated. I show you the first vote and the last vote, and then I'm going to go to the learning issue, which is important. So it's far away from zero. I'm not showing the p-values, but this is significantly different from. So I'm going to skip all the discussions about the difference, what we learn from this. From random dictator and reverse random dictator, these numbers are not significantly different. We learned that it's not only a fear of change. Okay, I'm going to skip the other comparisons because I have to run. So I show you. Yeah. So the other differences are not significant. So that is good in the sense that the result is robust. And doesn't seem to be triggered by pivotality or any of these things. But I want to show you that because Pedro, you found 50%. That's exactly what you should get if you do a horrible experiment. If you do very, very poor experiment, you should get 50%. But so this is a sad number. So what I want to show is that there is a logic between how these people are voting. Remember that for you to vote for the alternative game, you need to expect people to respond more than 50% to the change in the game. So you need to, an elasticity to taxes has to be, your belief about the elasticity of taxes has to be large. So I'm going to show two things. I'm going to show that subjects in average underestimate the effect of taxes on behavior, and second, those that underestimate the effect in a higher magnitude are more likely to vote for the prisoner's dilemma. These are histograms similar to ones that we saw yesterday about beliefs. So here what we have is a belief difference. This is Nash, 100%. You believe that the difference in cooperation rate between one game and the other is 100%. This would be the anti-Nash. Okay. It's actually the wrong, total elasticity in the wrong sign.
What's the empirical?
The empirical, like in the graph yesterday, is the red line. So you can see that the average expectation of the belief difference, the average elasticity is 35%. It's not really elasticity, but the impact that people expect is 35%, and the truth is more than twice that, 70-something%. This is random dictator and majority ones. We distinguish these two because they come from different previous experiences. And the same thing for reverse random dictator. The expected impact of the taxation is 30%, and in reality is 63%. Okay? This shows that there is an average underestimation of the effect of taxes on behavior. These graphs show that there is a correlation between underestimation of the effect and voting. So let me explain this graph a little. This is, in the left you have the prisoner's dilemma game, on the right the alternative game. These dots are the truth. Okay? That should be the belief. That should be the cooperation rate under PD, and this is the cooperation rate under the alternative game. So these 2 points are the truth. This red line, the broken line, connects 2 points, a point there and a point there, which is the belief of cooperation in both games, among those guys that voted for the alternative game. So these are the guys that voted right. Their beliefs are very close to the truth. What is more important, are closer to the truth than the belief of those that voted wrongly. These guys are the guys that voted for the prisoner's dilemma. They don't expect a big difference in behavior. In average, they have the sign right, but the magnitude of the difference of the effect is less than what is really going to happen. Okay? So this is nice because these guys have an estimate of the indirect effect that is less than is a true indirect effect. And therefore, notice the difference. This is only a 15% difference. These guys should not vote for the alternative game, and they don't. We have an issue of causality that of course, beliefs and behavior can both come from the same. It can be just exposed rationalization. So we have an instrument that arises from the game itself that gives us some evidence that that's not the case. This is also an issue of whether you fail to understand others or you also fail to understand yourself, and we can do some estimation to separate these two things. That's on the page.